Good morning, HOD Professor A.K. Chaturvedi sir, my seminar guide Dr. Shilal sir, seminar coordinator D.B. Sharma sir, faculty members, examiners and my friends. I am Jeetu Mahawar, pursuing my B.Tech from University Department of Mechanical Engineering, Rajasthan Technical University. My seminar topic is fuel from plastic waste. This is going to be our list of contents. First one is introduction. Plastic waste has become a significant environmental problem in recent years, with millions of tons of plastic entering our oceans and landfills every year. At the same time, there is a growing need for alternative sources of fuel to address concern around climate changes and energy security. One potential solution to these challenges is to convert plastic waste into fuel through a process known as plastic pyrolysis. This process involves heating plastic at high temperature in the absence of oxygen, breaking it down into its constituents, hydrocarbons, which can be refined into different types of fuel. Now the question arises that why do we need to convert plastic waste into fuel? The need of converting plastic waste into fuel arises several factors harmful for environment. Plastic take a long time to decompose and occupy significant space in landfills. By converting waste plastic into fuel, we can reduce the amount of plastic waste that ends up in the landfills. Increase in demand of energy. Waste plastic contains energy that can be recovered through conversion into fuel. By converting waste plastic into fuel, we can reduce our dependency on non-renewable fossil fuels and generate a source of energy from a waste material. Classification of suitable plastic for conversion into fuel. Plastic are made up of long-chain hydrocarbons and can be converted into fuel through a process called pyrolysis. However, not all plastic are suitable for conversion into fuel. Generally, plastic that are rich in carbon and hydrogen and the low levels of impurities are the most suitable for fuel production. Here are some plastics that are commonly used for fuel production. First one is polyethylene, polypropylene, polystyrene, polyvinyl chloride, and polyethylene terephthalate. Now, pyrolysis process. The production of fuel from pyrolysis is type of pyrolysis process called plastic pyrolysis. In this process, plastic waste is heated temperature in the absence of oxygen, causing it break down into smaller molecules that can be condensed into liquid fuel. Now steps. Collection and sorting of plastic waste, shredding and drying, pyrolysis, condensation and collection of fuels. In this process layout, we can see plastic pyrolysis process. Typically involves the following steps. Shredding and pre-treatment. The plastic waste is sorted and shredded into small pieces to increase the surface area for better pyrolysis reaction. The shredded plastic is then dried to remove any moisture and the impurities. Pyrolysis reactor. The shredded plastic is fed into the pyrolysis reactor, which is heated to high temperature of around 400 to 450 degrees Celsius in the absence of the oxygen. The heat causes and plastic to break down into smaller molecules. Condensation and collection. The gas and liquid products from the pyrolysis process are cooled and condensed to recover the oil and gas. The gas is collected and can be used to carbon black or as a fuel source of energy generation. Now, the advantages of plastic derived fuels. Reduction of plastic waste. Plastic derived fuels provide a solution to the problem of plastic waste management. It can convert plastic waste that would otherwise end up in landfills or environmental into a useful resource. Lower carbon emissions. The use of plastic derived fuels can result in lower carbon emissions compared to traditional fossil fuels. This is because plastic waste has a lower carbon footprint than fossil fuels, and the process of pyrolysis produces less carbon emissions than traditional refining processes. Now, energy recovery. The production of plastic derived fuels can generate a significant amount of energy. The fuel can be used in the various applications including transportation, heating and the electricity generation. Cost effective. Plastic derived fuel can be produced at relatively low cost compared to the traditional fossil fuels. This is because plastic waste is often readily available, can be sourced at a lower cost than crude oil. Versatility. Plastic derived fuels can be used in a range of applications such as fuels for vehicles, boilers and generators. It can also be blended with other fuels to improve the properties such as octane rating and the viscosity. Now some of the limitations are: it is energy consuming process. Plastic derived fuels has low calorific value and high viscosity. Future scope: the future scope of plastic pyrolysis is promising as it offers sustainable solution of managing plastic waste while also providing a valuable resource for energy production and chemical feedstock. Here are some potential future developments in plastic pyrolysis: advancement in technology, increased demand for sustainable fuels, expansion of waste management system, government support and license, development of new applications. This is all about the topic fuel from plastic waste. Thank you.